Hi, this is B. Charanjivara, Physics lecturer APRJC Tatipudi, in the chapter Moving Charges and Magnetism. In this particular video lesson, I will. Hi, this is B. Charanjivara, Physics lecturer APRJC Tatipudi, in the chapter Moving Charges and Magnetism. In this particular video lesson, I will teach about Ampere's law, Ampere's circuital law, and the application of Ampere's law and Biot-Savart law. Now, let us observe according to this Ampere's law, we can determine the magnetic field intensity due to a straight current carrying conductor at any point around this. That means it is a relation established between the intensity of the current in the wire and the magnetic field around the wire at any point we can determine. So it is very convenient to determine the magnetic field intensity due to a current carrying coil or a current carrying conductor. So using Ampere's law and Biot-Savart law. See, when you are discussing about Ampere's law, just you observe that this is a current carrying conductor. I am observing that, I am considering that this is a current carrying conductor, and this disc is a normal to the direction of current carrying conductor. The current is passing through this way. I'll just write down here. See, this is how you imagine the current is passing through this way, and you just using the right hand thumb rule, when this thumb indicates the direction of current, then the rest of the fingers curled, the direction of the curling gives the direction of magnetic field. So always when a current is passing, threading, this is what is called threading. When this is passing through this particular part, and the lines of force form normally on a plane, a circular plane, which is normal to the direction of the current. And in this case, if you observe, when a current is passing through this with the intensity I, it produces magnetic field. This field produced by this current is directly proportional. So magnetic field is directly proportional to I, and which is equal to some proportional constant, that is permeability of free space, mu naught. So mu naught times the current with which the conductor can produce the magnetic field. And I would like to find the magnetic field intensity at different places, at different circles. We can identify the magnetic field intensity at different circles due to the current carrying conductor. Now, suppose you just imagine that this is the current carrying conductor which carrying current I, and I would like to, and the magnetic field is formed in a circular loop. This is the circular loop. And at a distance, I would like to find the magnetic induction at this point, magnetic field at this point, small element. I consider small element of length dl. This is the small element of length dl, and its direction is the direction of B is in the direction of dl. At a what position? Say this is the center of the circle, which is the point where the conductor is passing through this particular circle, and this is the position vector, position where I would like to find the magnetic induction. So this magnetic field, say this conductor is capable to produce the magnetic field of V, that is proportional to the current I, and this can be made equal total magnetic field that can be produced by the current mu naught I, but this total current is due to the total elements in this particular circle, the total elements. The total elements means, I write here, magnetic field at this point B is equal to the total magnetic field by total length. Total length. So with this, I can write that the B into total length, that is the circumference. See, very small elements, such small elements are formed a circle. Small dls form a circle of circumference, certain circumference. So the total length is equal to the magnetic permeability multiplied mu naught multiplied by the current in the circuit. So I write here this B, the total length is nothing but the line integral of dl is equal to mu naught times I. Or this can also be written as closed integral B dot dl, of course this is the dot product, is equal to mu naught I. This is what is called Ampere's law. Now let us observe this with some example, how this can be found. Suppose, let us assume that this current carrying conductor is capable to produce a field, total field of 100 units. 100 units, say 100 Tesla. I write here 100 Tesla. It's capable of, this wire, capable of producing a magnetic field of 100 Tesla. Suppose if you go out of this conductor, normally the field will reduce. So I would like to find somewhere here, say at this particular point, the field will be, say, some 10 Tesla, 10 units. That means the total field is 100. Total field is 100 by total length 10. That is equal to 10 Tesla. Very clear? So the total field by total length gives the magnetic field at this particular distance. At this particular distance on this circle, 10 Tesla. Suppose I consider there is another circle which is a little bit more radius at a far distance. I would like to find the magnetic induction at the second circle. The total field that the wire can produce is 100 Tesla, but it is divided into more parts as at a more distance, the circumference increased. I just consider that this is 20. Then you will be getting 5 Tesla at this particular point. And suppose I imagine the third circle, the circular path, where the magnetic field I would like to find B at this point is equal to the total field that it can produce is 100, but the total length is increased here to extent of some 50. Then what happened? You will be getting 2 Tesla. So, as the distance from the conductor increasing, the magnetic field is decreasing. So, as the radius is increasing, the magnetic field is decreasing. So, we can finally write down that the magnetic induction, we can finally write down that the magnetic induction B is directly proportional to the current and inversely proportional to the distance. Therefore, if you combine these two, B is proportional to I by R. So this is how we can arrive the relation between the magnetic field and the current. Now if you observe the statement here, for Ampere law, the magnetic field created by an electric current is proportional to the size of the electric current with a constant of proportionality equal to the permeability of free space. So that is what I wrote here. V magnetic field total is equal to mu naught I. But V total is the magnetic induction at this point multiplied by the total length of the circular path, circumference. That is why I wrote here line integral of small particle dl considered as, for a circle it become 2 pi r. For a circle this become 2 pi r. See, the closed integral of dl, the closed line integral of dl can be written as 2 pi r. So, B into 2 pi r, B into 2 pi r is equal to mu naught I. For a straight conductor carrying current I, if you want to find the magnetic induction at a particular distance r, now B can be written as mu naught I by 2 pi r. Mu naught I by 2 pi r. So, from this one, we can write down that, I'll write here, we can write down that B is proportional to I and B is inversely proportional to R. So B is equal to some proportional constant mu naught by 2 pi into I by R. So we can obtain the magnetic induction due to a current carrying wire at a point at any position R obtained as mu naught I by 2 pi R. And now let us define the Ampere's circuital law. So it states that a closed line integral of magnetic field around a current carrying conductor is equal to the absolute permeability times the total current threading the conductor. Threading the conductor means, say for example, I just observed, you just observe this. This is a current carrying conductor. This is a current carrying conductor, and just you see the current is passing through this way, and you can imagine the magnetic field at any point on different circles, and you want to find the magnetic induction at this point. This is the position vector, and the direction of this is, see, very clearly observe this, and this is the position vector, and this element is the magnetic field intensity, this element, and I just write here, this is the position vector, and I would like to find the magnetic field at this point and this point. I just consider a small element like this, and what is the angle between these two? It is 90 degrees. Element and the position vector, it is 90 degrees. And the magnetic field is also in this direction. This is the magnetic field direction when it comes to this point. So all these magnetic field elements are coplanar, parallel to the plane and perpendicular to its position vector at any point. And now you can write down threading. So if the conductor placed like this, you cannot apply this law. If the conductor somewhere here, current carrying conductor, you cannot apply. It has to go and come out of this particular loop. Then only we can apply this law. So it states that, Ampere circuit law, it states that the closed line integral of magnetic field around a current carrying conductor is equal to absolute permeability times the total current threading the conductor, which passes through the loop. So this is what is called the Ampere's law. Or we can also state in the other way, the line integral of intensity of magnetic induction field around any closed path is equal to mu naught times the net current across the area bounded by this path. Then what does it mean? Now I will draw some closed path due to different current conductors through that loop. What will be the net current and what will be the net field at any particular point? Suppose we imagine there is a closed path, and this is the magnetic field line, closed line, and if you consider the currents at different points, say I write here, this is I1, this is I2, and this is I3, this is I4. So there are different conductors. In one case, suppose if the current is passing into the board, I write here it is plus. Into the board, I write here it is plus, the direction of current. And if the current is coming out of the paper or the board, I write here it is minus. Current is plus if it is entering into the paper, into the board, or I take minus current if it is coming out of the paper. So into the paper and out of the paper for our convenience. And somewhere here there will be some wire here into the paper, somewhere here. So I write here into the blackboard, the current into the blackboard. Here into the blackboard. Why? say some I5, and somewhere here, out of the blackboard, I write here I6. So this will be a current minus and this will be plus. So I would like to find the magnetic induction at this particular point, a small element dl. And we have to, this is the magnetic field in this particular position, is in the tangent drawn at that point. Then what is the net current due to this different currents in the enclosure, closed mesh, closed circuit? Then the net current here I is equal to, how many positive currents are there? Plus I1 plus, this is minus I2 and plus I3 and minus I4. So this is the net current produced here. So that is what I told, net current enclosed in that particular closed circuit. And these two currents are out of this circle, out of this closed circuit. It will not be taken into consideration. So we will take only the currents which lie inside the closed circuit. So the net current enclosed this particular part is I is equal to I1 plus I3 minus I2 minus I4. So this is what you have to apply as the net current enclosed in this particular closed path. So now the integral B dot dl is equal to mu naught I. This is the Ampere circuital law. For B dot dl, as you know, it is a scalar product. The B dot dl can be written as B dl cos theta, as it is a dot product. Now using this, you can write down here Ampere circuital law, B dl cos theta is equal to mu naught I. So using this formula, we can find the magnetic field intensity due to a straight wire carrying current I at any point P at a distance R. This is the application of the Ampere's law. Now let us find the magnetic field at any point using Ampere's law. So in this concept, magnetic induction due to long current carrying conductor at any point B. So for this, let us consider a conductor carrying current I. Consider current in the wire, current in the conductor is I. So when current is passing through this, the magnetic field will be produced. The magnetic fields are closed loops. Somewhere here, the closed loop. I would like to consider a point P which is at a distance R, and this R represents position vector. This R represents position vector of the point P. And this point P, and I just consider a small element here of length dl, and the magnetic field will be in this direction. The small magnetic field is dB. And I would like to find the magnetic field at this point P using the Ampere's law. We can determine the magnetic field at this point. So what is the angle between this magnetic field and position vector? It is 90 degrees. The magnetic field and position vector is 90 degrees. So, as you know, the closed integral B dot dl according to Ampere's law is mu naught I. And B dot dl, what is the angle between B and dl? So this is the angle between B and this is the R and this is B. The angle between these two is 90 degrees. And here B and dl is 0 degrees. So here it is B and dl is 0 degrees, not 90. But the angle between dl and the position vector is 90 degrees. So B and dl are in the same direction. So angle between B and dl is 0 degrees. Therefore, I write here this closed integral B dl cos theta is equal to mu naught I. Since theta is 0, this becomes 1. So I write here closed integral B dl is equal to mu naught I. In this case, since dl, small element, is in the direction of B, so I write here B dl are parallel to each other. B dl are parallel to each other everywhere, wherever you consider on the same plane. The dl and B are parallel. And now you can write down this as B closed integral dl is equal to mu naught I. But this closed integral dl, such small elements lie on the circumference of the circular of radius r. Then what happened now? So B, instead of closed integral dl, you can write down it is the circumference of the circular loop, circular path of radius r is equal to mu naught times the current in the conductor. So you can find the field at this point. Field at this point is B is equal to mu naught I by 2 pi r. So this is the expression for the magnetic induction due to a straight current carrying conductor at any point P which is at a perpendicular distance from the center of the or from the conductor R. Now let us solve some problem basing on this. Now let us observe this problem. A long straight wire carries a current of 35 amperes. What is the magnitude of the field at a point 20 centimeters from the wire? So this is the problem given. And for solution, a straight wire, long straight wire carrying current I is given 35 amperes, and this wire produces a magnetic field, and we have to determine the magnetic field intensity B at a distance R is equal to 20 centimeters. So given this point, we have to find B at this point B. So for this point, we derived the expression from Ampere's law. B is equal to mu naught I by 2 pi r. This is the necessary formula we have to apply. But what is the data given here? You know, mu naught is equal to 4 pi into 10 power of minus 7 Henry per meter, or Tesla into meter per ampere. Now the current is given, I is 35 amperes, and the radius is given 20 centimeters, but we have to convert this into meters. That is most important. And you substitute these values in this equation, then B is equal to C, mu naught is how much? 4 pi into 10 power of minus 7 into 35 whole by 2 pi r. 2 pi into, what is r? 20 into 10 power of minus 2. This is the value we have to observe. And now if you simplify this, 2 by 2's, and this become 0.2 or 10 power minus 2 become. So I write here 2 into 35 into 2 into 35 into 10 power of minus 5 whole by 20. So now this become 10. So this become 3.5 into 10 power of minus 5 Tesla. So this is the answer for this problem. This is how we have to determine the magnetic induction due to a current carrying straight conductor. So in this, now let us observe the next concept. Magnetic induction at the center of a current carrying circular coil using Biot-Savart law. So magnetic induction at the center of, see for example, just you imagine this is a wire carrying current. Now let us imagine that this is the wire, circular coil, the wire, in which the current is passing through this way. Again you can apply the, if current is passing through the circular coil, it produces magnetic field. Again you can apply the thumb rule. If the curling that gives the direction of current and the field gives the direction of the thumb. Suppose you just imagine that. So this is the way in which I just write here like this. And now we have to consider a circular coil. This is the circular coil which is carrying current I, and we have to find the magnetic induction at point. This is, I consider this is center O, and you consider any small point element on the wire. Say this is the small element which is carrying current I in this. So we can write down this ideal bar is in this direction. Ideal bar is in this direction. So I just consider a small element dl, and the ideal bar is in this direction. And this element considered at a distance of position vector represented by the position vector r bar. This is a position vector r bar. Now we are going to find the magnetic induction at this point. I write here this point P. At point P, due to this circular current carrying coil, I consider at point P the magnetic induction due to this current carrying element can be observed at the center O is B. I write here the magnetic field due to the small element is dB. Due to this small element is dB, and the total field due to all the small elements is equal to B, total field. So this is dB, small element field produced due to this magnetic field at this point. Now what we have to do? We have to apply the Biot-Savart law. What is Biot-Savart law? According to Biot-Savart law, Biot-Savart law, closed integral, not like that, B is equal to mu naught by 4 pi ideal sin theta by r square. This is what is called Biot-Savart law. So magnetic field induction B at this point is equal to ideal sin theta by r square. For this is a small element, for small element. So I write here for small element it is dB, mu naught by 4 pi ideal sin theta by r square. Since theta is 90, it is the angle between dl and r. It is the angle between dl and r. This is 90. Since theta is 90 degrees, we can write down the magnetic induction dB is equal to mu naught by 4 pi ideal by r square. Now what we have to find is the total magnetic field. So in order to get the total magnetic field, we have to integrate the equation. On integrating, we get the total magnetic field. So integrating this part throughout the circular path, we can get the total magnetic field at this point. So on integrating, so integral dB is equal to integral mu naught by 4 pi ideal by r square. So now integral dB is the total magnetic field B is equal to, so mu naught by 4 pi is a constant value and I by r square. are also constant. So I write here mu naught I by 4 pi r square integral dl. So this is equal to mu naught I by 4 pi r square. Integral dl is the circumference of this circle of radius r. So I write here this is 2 pi r. So finally we can write down b is equal to, so 2 by 2 times this is cancelled and r square can be cancelled. So I write here this is mu naught I by how much? R square and r can be cancelled. So we will be getting 2r. This is mu naught I by 2r. So the final expression for magnetic induction due to a current carrying circular coil at the center is B is equal to mu naught I by 2r. So B, if there are n turns, this we have considered only one circular coil, but if there are n turns like this, so there are n turns, then we have to multiply this with n. So we get B is equal to mu naught Ni by 2r for n turns. So this is the magnetic induction due to a circular current carrying coil with n turns, which is having a radius r and the current in the coil is I. This is how we can determine the magnetic induction due to a current carrying coil using Biot-Savart law. Now let us solve some problem basing on this current carrying coil. A circular coil of wire consisting of 100 turns, each of radius 8 centimeters, carries a current of 0.4 amperes. What is the magnitude of the magnetic field at the center of the coil? So now let us observe this, solve this problem. Now you just consider there is a coil consisting some number of turns and a current is passing through this, and you have to find the magnetic field at this position at the center of the coil. So what is the data given here? What is the formula required? See, B is equal to mu naught Ni by 2r. This is the formula to determine the magnetic field at the center of the current carrying coil. So mu naught is 4 pi into 10 power of minus 7 into number of turns. How many turns are given? 100 turns. This is 100 turns into, what is the current given? 0.4 amperes. And by 2 into, what is the radius given? 80 centimeters. So 80 into 10 power of minus 2 meters. So this is all we have to substitute in the formula the given data. So now you can simplify this. After simplification, just you cancel this 2 times, and this 2 minus 4 will become 2 square and 4, and this become 10 power minus 3, and this become 10 power minus 4. So finally you will be getting as 3.1 into 10 power of minus 4 Tesla. So this is the answer for this problem. Okay, now let us write down one more step for this. Let us write down one more step. Say this is equal to 2 into 3.1 into 10 power of minus 7 into 10 cube 10 square 10 square into 4 into 10 power of minus 1 whole by 8 into 10 power of minus 1. So now what happened? You see, 2 4s, and this 4 can be cancelled, and this become 3.1 into, so when it goes up, this can be cancelled, and how much? This will be 10 power of minus yes, this is not actually 80, this is 8 only. So you will be getting 10 power of minus 2, and finally you will be getting 3.1 into 10 power of minus 4 Tesla. So this is the final answer. When it goes up, 10 square, 10 power 4, 10 power minus 3, and minus 7. So you will be getting 10 power of minus 4. This is how we can solve the problem. Now let us solve one more problem basing on force on current carrying conductor placed in a uniform magnetic field. See, what is the magnitude of magnetic force per unit length on wire carrying a current of 8 amperes and making an angle of 30 degrees with the direction of a uniform magnetic field of 0.15 Tesla. Say for this, let us see what is the data given. The magnetic force per unit length you have to find. The data given, the formula required is force on current carrying conductor is, you know, the formula L cross B. This we can write down as ILB sin theta. This is the force, formula for force. See, this is the magnetic field induction of B and a current carrying conductor which is carrying a current of I, and this is making an angle 30 degrees. This is making an angle 30 degrees. So we have to find whatever the length may be, conductor, but only we have to find the force on unit length, that is equal to 1 meter. We have to find the force on the length of 1 meter. So what we have to do? So the force is equal to I. What is the current on this? 8 amperes. What is the length? Because we are going to find the force on 1 meter. That is why I write here 1 into B. How much? 0.15 Tesla. And sin theta, that is sin 30. It's given sin 30 degrees. So now let us simplify this. 8 into 0.15 into half. So this becomes the force per unit length. Become how much? 4 into 0.15. That is equal to 0.6. Force per unit length means Newton per meter. So what is your final answer? Force on this current carrying conductor in this magnetic field is 0.6 Newton per meter. This is the solution for this problem. Now let us observe the force between two straight parallel current carrying conductors. What is the force per unit length between the two conductors carrying current? Suppose you consider, let us consider two conductors. This is one conductor, this is another conductor. Say the current in this conductor is I1, current in this conductor is I2, and the length of each conductor is say L. The distance between the two conductors is say R. Now, if the current I1 and I2 is flowing in the same direction, then what happened? The current carrying in this conductor, I write here this is a conductor AB, and I write this is conductor CD. So in AB, as the current is passing through that, if this produces magnetic field around this, this will produce a magnetic field around this. This will produce a magnetic field around this. And similarly, the magnetic field at this point is due to the current in AB. This one is, I write here this is B1 is equal to mu naught I1 by 2 pi R. This is the magnetic induction due to this current I1 at a distance R. Now, the same way as the current is also flowing through conductor CD, this will also produce the magnetic field. So the magnetic field due to this current carrying conductor due to I2 at this point, I write here B2 is equal to mu naught I2 by 2 pi R. So, because of this current carrying conductor I1, the field produced here, and because of this current carrying conductor, field produced at a distance R is equal to mu naught I2 by 2 pi R. Then, this conductor is placed in a magnetic field of B2, and this conductor is placed in a magnitude of field B1. So, when a current carrying conductor is placed in a magnetic field, it is influenced by some certain force. So, the force on this conductor due to magnetic field produced by this conductor is, I write here the force at this point F2. I write here for second conductor F2. In general, what is the formula for F? Force on current carrying conductor is B I L. Since sin theta, theta is 90. So, I write here F2 is equal to force on second conductor CD is equal to B. What is the magnetic field here? It is B1. So, I write here it is B1. And what is the current in the second conductor? I2. What is the length of the conductors for which we are considering the force for length of L? So what is B1? Mu naught I1 by 2 pi r into I2 into L. So similarly, now you can write down this as the force on this conductor is mu naught I1 I2 by 2 pi r into L. So force per unit length is equal to mu naught I1 I2 by 2 pi r. This is the force acting on this conductor. So now you can identify the force direction. You can identify the force direction and the direction of V1 and V2 using Fleming's left hand rule. See the current here, the field is in this direction and here in this direction. So now let us find the force on this one, AB, force on AB. Now let us see what is the force on AB. In the same way, you can write down the force F1 is equal to, force on this, F1 is equal to B2 into I1, current, into L. So this is equal to, what is B2? Mu naught I2 by 2 pi r into I1 into L. So what is the force acting per unit length? F1 by L is equal to mu naught I1 I2 by 2 pi r. So these two forces are same. These two forces are same, identical. So now we can write down in general force per unit length between the two conductors is equal to mu naught I1 I2 by 2 pi r. This is the formula for the force acting between two conductors. Now we can define ampere from this formula. From this formula, we can define ampere. See, for example, if you take I1 is equal to I2 is equal to 1 unit, they say for example 1 ampere, it will be considered as 1 ampere. If the distance between the two conductors is 1 meter and if 1 unit of current is passing, said to be 1 unit of current is passing, if force per unit length is equal to, what is the force per unit length? Mu naught 4 pi into 10 power of minus 7 into 1 into 1 by 2 pi into 1. So that is equal to 2 by 2's. So this becomes 2 into 10 power of minus 7 Newton per meter. So if I1, I2, to be 1 ampere, I1 and I2 to be 1 ampere. If these two conductors are separated by 1 meter distance, if the force of attraction or force of repulsion between the two conductors is 2 into 10 power of minus 7 Newton per meter, then the current passing through the conductors is called 1 ampere. So we can also define as the current required between the two parallel conductors when they are separated by a distance of 1 meter, then they have to either attract or repel with a force per unit length is 2 into 10 power minus 7 Newton per meter. Then the current passing through that conductors is called 1 ampere. Or in the other way, let us define. If 1 ampere current is sending through the two conductors separated by a distance of 1 meter, if they repel or attract with a force of 2 into 10 power of minus 7 newtons per unit length per 1 meter, that is called the 1 ampere. So this is how 1 ampere can be defined. Now let us write the statement. Now let us define the ampere. When two infinitely long parallel conductors carrying the same current are separated by unit distance, attracts or repels with a force of 2 into 10 power of minus 7 Newton per meter, then current flowing through each conductor is said to be 1 ampere. That is what we have already discussed. So this is the definition of ampere. Now let us solve one problem basing on this concept. Now let us see this problem. A current of 10 ampere passes through two very long wires held parallel to each other and separated by a distance of 1 meter. What is the force per unit length between them? So for this, what we have to do is, let us let us write the formula for this. Force per unit length between two parallel conductors is equal to mu naught I1 I2 by 2 pi r. So the one thing we have to remember, if the currents in two conductors are passing in the same direction, then the two conductors will attract. If the currents are in opposite direction, the force between the two conductors is repulsive force. This is most important. If the currents are passing through the conductors, say this is I1 and this is I2, then these two currents are in the same direction, then there will be attractive force. The force will be attractive. Since the field will be in this direction and the field in this case will be B2. So the force is attractive in this case. So if they are anti-parallel, if the current is passing in the opposite direction, then they repel each other. But anyway, we want to find the force of attraction or repulsion per unit length. So I1 and I2 is given 10 amperes. So I write here for mu naught 4 pi into 10 power of minus 7 into I1 and I2. 10 amperes into 10 amperes. So identical current by 2 pi into R. R is given a distance of 1 meter. Distance between these two conductors is 1 meter. That is R. So I write here 1. So 2 by 2's. So this is equal to how much? 200. 2 into 10 power of minus 5 Newton per meter. This is the force per unit length. 2 into 10 power of minus 5 Newton per meter. So this is how we have to solve the problem. If the currents are in opposite direction, then this will be attractive force. Okay.
Good morning, students. I am Shyamala from Sitanagaram KZBV, Vijayanagaram district. Okay, today I would like to explain vocabulary. This vocabulary topic in intermediate second year grammar part. Okay, today I will explain that vocabulary, but before we have to go into the topic, I will explain, I will give to the one example for you. Okay?
Ready?
Now, classroom. Classroom word. Look at this. Classroom. This word we have to listen means we can recall some more words in your brain. What are those? In classroom have some words. Those words have blackboard and duster, chalk, notes, bench, charts, books and pen and pencils. These are also new words. These are also words in the related to the classroom words. Related to the classroom words. These are we call the classroom vocabulary. We call the classroom vocabulary. Just this is for your understand. Understand means we have to give in the just example for you. Okay, na? That is the classroom vocabulary. Now, please look at this. What is vocabulary? And what are the root words in English vocabulary? And the related words, root words in English vocabulary. And fourth one, exercises related to vocabulary. These 4 questions also based on the explain to the vocabulary. Okay? Now, first one, what is the vocabulary? What is the vocabulary? Now we have to explain that introduction. Introduction of the vocabulary. Look at this. Vocabulary plays an important role in learning language. Okay, na? Vocabulary plays an important role in learning language. If any language also we have to learn, we want to the vocabulary. We have to learn vocabulary. So why we have to learn vocabulary? So that is the develop our communication. Our language. If any language also we have to learn. First we have to learn vocabulary. This is the most important in our language learning. Okay, na? And next one. And vocabulary improve our communication skills and reading and writing abilities. Here vocabulary is improve only communication skills and reading and writing skills also. These are also abilities also we have to improve from to vocabulary. Okay, now? So communicate. Actually we have to learn first we have to vocabulary. That's why we have to communicate with others. How do we have to communicate with others? That is a base words. Also we have to learn in the here. Vocabulary improve our communication skills and reading and writing abilities also we have to develop from vocabulary. And next one. And it is a not matter at the phase of education, your vocabulary develop can benefit for everyone. In education time, we have to, everyone also must and need, we have to learn the vocabulary. In education system, we have to develop, we want to vocabulary. We want to vocabulary. Okay, for example, every morning, some people also reading the newspaper. Why they are reading the newspaper? Because they can develop the vocabulary. Because they can develop the vocabulary. Means here English newspaper we have to learn, read. Then we have new words also. Every day so many new words also improve in the newspaper. That's why we have to underline those words and we have to develop the vocabulary. Like that, we have to improve our language, how to communicate with others. Without we have to develop vocabulary, how do we communicate with others? No use. That's why everyone also maintain our vocabulary every day. Update we have to learn. Every day also we have to develop the vocabulary. Then we have to communicate with others and reading and writing skills also. And in our future, our education time also we have to can easily our education system. Okay, are you understand what is that vocabulary? Now, for example, one more example for you. Okay, now present, what is the situation? That now present situation is a pandemic period. What is that? Corona, COVID-19. Now this corona is, what is the corona? This corona related some words also have here. What are those? Now corona is the base word. What is this? Corona is the base word. So this corona base word means this is the related words also have. Already we have to learn so many. What is the first one? Corona related words: immunity, and sanitizer, mask, quarantine, social distance, isolation, quarantine. These are also related with the corona. This corona related vocabulary this is. That is called the related vocabulary. That is the related vocabulary. Are you understand how to we have to connect the vocabulary? So like that, we have to base word. When we have to learn the vocabulary, that is the base word we have to learn. After we can get the what is the related words. What are the related words we have to learn. Okay, are you understand? Now, root words in English vocabulary. Now, what are the root words? Actually, here vocabulary means new words, base words, and word power. These are also called the vocabulary. Okay, now come to the subject. Actually, here given so many words, so many new words. These words also have the root words. Now we have to first root word. What is this? Anthrop. What is this? Anthrop. Actually, anthrop means what is that? Human being. What is the anthrop means? Human being. And next one. Next word. Anthropometry. What is the anthropometry? Look at this. Anthropometry means study of the measurements and proportions of the human body. So, study of the measurements and proportions of the human body. Okay, now this is the anthropometry. And next one, misanthrope. What is that? Misanthrope. Misanthrope means what is that? One who hates mankind. Who hate the mankind, we call those. What is that? Misanthrope. Next one. Anthroposophy. Anthroposophy means here knowledge or understanding of human nature. Knowledge or understanding of human nature. Now here Anthroposophy means here knowledge and understanding of human nature. Okay, are you understand? Means here look at this. Anthropology and what is that? Philanthropy and anthropoid and anthropophagy and anthropocentric. And these are also called the anthropology. Means here anthrop means human being. Human being means anthrop means human being. Okay, are you understand? These are also called that look at this. The study of the being of human. The study of human being. Are you understand? Like this. Anthropology. Here ology means study. Even any what is that study? Any studies also we have to call that ology. We call the here ology means study. Okay, are you understand? The study of the human being. Anthrop means the study of human being. That is called the anthropology. Even any place also given this anthrop, misanthrope and anthropoid and philanthropy. These words we have to listen means we have to blindly identify what is the, this is the human being, this is the human being, or this is the human related word, human related word. This is the root word of the human. So that is word is called the anthrop. That anthrop means human being. Are you understand? This is the anthrop. Next one, look at that. Second one, lok. What is that? Lok means talk. What is this? Lok means talk. Talk means lok. Are you understand? Now look at this. These are also related words of the lok. Okay. This is that. What is the base word? This is the called the root word. This is the root word. We call the another name also base word. Are you understand? Okay, this loku have related vocabulary. Related vocabulary. What are those? Actually, these are also related about talk. About talk. That's why these are also given to the meaning talk, but not have any difference. But have some synonyms like we have to have same meaning, but that is a difference. Have words. Look at this. First one, eloquent. Eloquent means what is that? Beautifully expressive talking. Beautifully expressive talking. Eloquent means beautifully expressive talking. Okay, are you understand? Beautiful. Who is somebody also talking very beautifully expressive talking? Then we have to express them, those talks, talkers. Okay, now next one, soliloquy. Soliloquy means talking by one person. Talking by one person. Soliloquy means some persons also talking themselves. Okay? Themselves also talking. But don't talk to others. Those are also talking themselves. That is called the soliloquy. Talking by one person. And next one, loquacious means talking a lot. So many talking. So much talking. So every time also talking like that. And loquacious means talking a lot. And colloquy. Colloquy means formal talking. Colloquy means formal talking. Formal talking means colloquy. Are you understand? Colloquy means formal talking and loquacious means talking a lot, and soliloquy means talking by one person, and eloquent means beautifully expressive talking. And next one, circumlocution means talk in roundabout way. Talk in roundabout way. Here circumlocution means we have to our surrounding. Who was the persons also have? Those persons we have to talking. That is the around, talk in roundabout way. Okay, next one. Elocution means act of talking beautifully. Okay, beautifully. Act of talking beautifully. Elocution means some readers and TV anchors, those people also talking like this. Public service people talking like this. Elocution means act of talking beautifully. Okay, now next one. Interlocutor. Interlocutor means a person who takes part in dialogue or conversation. Interlocutor. Interlocutor means a person who takes part in dialogue or conversation. Means one person also taking that dialogues or conversations. That is that. And next one, grandiloquent. Grandiloquent of overblown. Overblown means grandiloquent of. Now next one, ventriloquism. Ventriloquism. And ventriloquism means talk without moving lips. Moving lips means here talking without moving lips. Without our lips don't moving and talking then. How to talking? Somebody, what is that stage shows already? Somebody also one doll have bring and they can speak. Speak them to dolls. Those are also speaking, but they don't speak out. How like to moving lips? Don't moving lips. That type of talking. Are you understand? What is this? Ventriloquism means talk without moving lips. Are you understand? This is called these are also related words to the talking. Okay, that is called, the root word is loque. Loque is the root word of the. So, are you understood? These are also loque. Loque word is also related vocabulary. This is the root word of the loque. That is a base word also. Okay, this is the base word on root word. That's why these are also called the, what is the talk. These words are also introduced about the talking. Okay, talking is a beautiful talking and formal talking and talking without moving lips. These are also telling about the talking. So this word we have to listen. We have to, you can see, loque means immediately we have to write in the examination easily. How to? In your brain you have to keep like this. Yes, loque means talk. Whatever these words also, whatever you have to see, then you have to blindly write about the talk. Okay, are you understand? Comes next one. Okay, now next one is third. Okay, cron means time. What is this? Cron means time. This is the root word. This is the meaning. What is the time? Cron means time. This is the vocabulary. Cron vocabulary, related vocabulary. This is. Look at this. Chronicle means events of time. Chronicle means events of time. This is the vocabulary. And next, chronometer device. Chronometer device means measuring of time. And chronological means time sequence. Chronic partning means to time. Chronic means partning to time. And next one is anachronism. Anachronism means wrong time. What is this? Anachronism means wrong time. And synchronize means happens at the same time. Synchronize means happens at the same time. And chronometer device means measuring of time. These are also words related to the time. Okay, this cron means base word. This is called the root word. This root word related with the vocabulary. What is this vocabulary? About the time. I mean cron. Cron related words. That's why we call that related vocabulary. Cron related vocabulary also these. Are you understand? Okay na? Are you? Cron means wherever we have to see cron. This is the related to the time. Like that we have to understand. Okay? Are you understood? Next one. Okay. Now next one is fourth one. Fourth one is morph. What is this? Fourth one is morph. Morph is the root word. Morph is the root word. Now here look at the back image is the tree. Tree picture. Are you understood? Are you? Look at this. This is the tree. What is the tree? Have the roots in the ground. Like that here. Morph also a root word. Morph also root word. Root word means what is the shape and form. At the like that, how to have the tree branches like this. These words also have a like branches of the morph. Are you understand? Okay. Now look at the related vocabulary. Morph is a shape and shape or form. These are also meaning of the morph. And these words also based to the root word. Okay. Look at this first one. Ectomorph. Ectomorph means with lean and muscular body. What is that? And with lean and muscular body. Lean means very thin person. Very thin person. We call like that. And next, morphology means study of morphemes. Study of morphemes. Already I am said in first one. Ology means study. Ology means call the study. Okay, study of morphemes. Morphology means study of morphemes. And morpheme means shape of a unit of a sound. Shape of a unit of a sound. And now, next one. Amorphous. Amorphous means having no fixed shape. Here, amorphous means having no fixed shape. Actually, he does not have a particular shape. That is called having no fixed shape. We call amorphous means. And polymorph. What is the polymorph means? And change into many shapes. Polymorph means is more than 2 or 3. We call the poly. Now here polymorph means change into many shapes. Okay. And mesomorph. Mesomorph means compact and muscular shape. Compact and muscular shape. Next one, endomorph. Endomorph means plump body shape. Actually here, lean or muscular body, this is the opposite is the endomorph, is a plump body shape. Plump body shape. Here lean muscular body and here plump body shape. That is called the endomorph. Are you understand? These are also related vocabulary to from what is that? Morph. What is the root word of the morph? This is the base word of the in fourth one, shape or form. Are you understand this vocabulary? Now next one. Graph. Next one and fifth one is graph. What is this? Fifth one is graph. Graph is a root word. Graph is here root word or base word. Actually graph means what? Write. What is that? Graph means write. About the writing. Graph means about the writing. Okay, now look at this. First one. Autograph. Autograph means self-written. Self-written. And we have to go to the celebrities. We have to ask the what is that? Autograph please. Autograph please. Like we have to ask no. Like that self-written. We call the autograph means self-written. And telegraph. Telegraph means writing from a phone. Writing from F for. Who is our relatives or friends have an for? Then we have to write the writing from F for telegraph. Is communicate with telegraph. Are you understand? That is that. Telegraph is meaning of writing from F for. And next one, graffiti. Graffiti means writing on walls. Writing on walls. Graffiti means we have to call the meaning of writing on walls. And next one, photography. What is this? Photography. Actually already you know what is the photography. Photography means writing of pictures by using light. Okay. This is very easy word. Already you can understand. Photography is a writing of pictures by using light. And next one, cinematography. Cinematography means the writing of film scenes. The writing of film scenes. Okay, movie scenes. So many scenes also have in movies. That is called the cinematography. What is that? Cinematography. And next one, choreography. What is that? Choreography. Choreography means we have to listen this word in so many programs. In dance programs we have to listen this word. Choreography. That is called the writing of dance steps. Writing of dance steps. Already easily you can understand these words. This word. And next one, cartography. Cartography means writing of maps. What is that? Writing of maps. And next one, seismograph. Seismograph means write Earth's movements. Our Earth is how to movements. That is a study to seismograph. Seismograph. Next one, calligraphy. Calligraphy means beautiful writing. Calligraphy means beautiful writing. Who is writing with beautiful writing? That is called the calligraphy. Okay. Now, bibliography. Bibliography means writing about books used. How do we have to use the books that is written from is the bibliography. Okay. Now, biography means writing someone's life story. Biography, writing someone's life story. So, these are also telling about writing. What is that? Telling about these words also. Writing, telling about the writing. That is called the root word. Graph means write. Write means graph. This is a graph related vocabulary. Are you understand? Yes. Come next one. Now next one is sixth one. Sixth one is wet. What is that? Wet. Wet means turn. Here wet is the root word. Okay? Root word is the base word. And that is the means of turn. That is the wet means turn. Okay? Now look at this. First one is convert. Convert. Convert means thoroughly turn. Thoroughly turn means is a change fastly. That is the change fastly. That is called the convert. Thoroughly turn. And revert. Revert means turn back. Turn back. We have to turn back. That is called that revert. And vertical. Vertical means turn up. Vertical means turn up. And invert. Invert means turn upside down. Turn upside down. Okay. Now, introvert. Introvert means turn within. Turn within. Okay. Next one. Avert. Turn away. Avert means turn away. Turn away means avert. Are you understand? Okay. Extrovert. Extrovert means turn outward. Turn outward. Extrovert means turn outward. Turn outward means extrovert. Next one. Subvert. Subvert means to corrupt. To corrupt. To corrupt means subvert. And divert. Divert means turn. And turn form. Turn form. Divert means we have to divert one thought, another thought we have to change immediately. That is called divert. Divert means we have to change. Okay. Now, advertisement. Advertisement to which turns towards a product. Already, advertisements means you know already. What is that in TV shows? I mean, in between or some serials and movies also coming in the between of the movies. I mean, middle of the movies and serials also coming to the advertisements. Okay, to which turns towards a product. Product advertisements. Okay, now next one. Pervert. Pervert means to thoroughly turn away from normal behavior. Okay, thoroughly turn away from normal behavior. Okay, that is called pervert. Okay, these are also related word. Related vocabulary is word. Related vocabulary from word. Okay, this word we have to listen in examination or anywhere. That is, we have to turn. That is called the turn. You have to keep in your brain turn. That means turn. Whatever we have to see in this word, then you have to immediately guess. This is like it. This is the meaning of the turn, like that. Okay. Now next one. Yes. Next one is spect. Next one vocabulary. I mean root word is spect. Spect means see. Okay. Root word is spect. What is the meaning of spect? See. This is the base word. This is the meaning of the word. Okay. Spect. Spect means see. Now look at this. Speculate. Speculate means to think. We have to think about anything also. We have to call the speculate. Speculate. Next one. Spectacular. Spectacular. Okay. Means what is that? Impressive enough to be worthy of seeing. Impressive enough to be worthy of seeing. Okay. Now, spectator. Spectator means one who sees an event. Any event also happen. One person is a lead the event. That is called the spectator. That person we have to call the spectator. One who sees an event. Okay, are you understand? Now, perspective. Perspective means a view. What is that? A view. Actually, this is the I am given the short meaning. Actually, in those have two meanings in the textbook, but I am given in simple meaning. We can easily understand. Okay. Perspective. Perspective, a view. And spectacle. Spectacle means something which is seen. Something which is seen. We call the spectacle. Okay, spectacle means, actually here look at this. Spectacles means eyeglasses. Spectacle means eyeglasses. Here spectacle not has here not adding the s. That's why we have to change the meaning. Something which is seen. Something which is seen. Here spectacles means eyeglasses. Okay. Despicable. Despicable means viewed with scorn. Viewed with scorn. And next one. Spectra. A ghost or phantom. Spectra means a ghost or phantom. Okay. Phantom. And inspect. Inspect to look into carefully. Inspect means we have to look into carefully. Even anyone we have to given any responsible to us, then we have to look into carefully that situation. That is inspect. And suspect. What is the suspect? Seeing with mistrust. We have to suspect means seeing with mistrust. We have not have the trust there. That is called the mistrust. And respect means what is that? To see someone in good way. Respect means what is that? Even elders and our parents, on teachers, those we have to give into the respect to them. That's why that is called the respect, to see someone in good way. That is the good way we have to. Okay, are you understood? These words also telling about the sea, telling about the sea and look. Okay, these words audio we have to understand. Okay, spec means sea. Now comes next one. Okay, now next one. Look at this. Next root word is jet. What is that? Jet. Jet means throw. Jet means throw. What is the throw? Throw means sometimes we have to reject some, like throw means, and through also. What is that? Now look at these words. Trajectory. Trajectory means the curved path of an object thrown into a space. Thrown into a space. Trajectory means the curved path of an object thrown into a space. Like this. Next one. Jettison. Jettison means throw out. Jettison means throw out. Outside of we have to throw or push. That is. And subject. Subject means throw under. What is that? Throw under. That is called subject. And object. Object means throw in the way. Object means throw in the way. Reject. Throw back. Reject means throw back. We have to throw back side. And eject. Eject means throw out. Eject means throw out. And project and throw forth. Throw forth. And inject, throw in, and interject, throw between. Okay, inject. Inject means throw in. Injection. We have to take the injection, then that is the throw in. Okay, na? Inject. That drug is coming to our body. That is called the throwing. That is inject. Interject. Interject means throw between. Throw between. That is called the interject. Okay. Now, dissect. Dissect means throw down. Dissect means throw down. Here reject means throw back. Here dissect means throw down. Eject means throw out. These are also we have to indicate the throw. Okay. Throw means ject. Here ject is the base word. That related vocabulary is telling to the throw. Telling to the throw. Okay. Are you understood? And now next one. We have to go to the next one. Next root word is form. Next root word is form. So what is the form root vocabulary? Now look at this. Form means shape. Form means shape. Okay. First one, transform. What is that? First one is transform. Change shape. Transform means change shape. And next one, cruciform. Cruciform means shaped like a cross. Shaped like a cross. Shaped like a cross. Cruciform. Cruciform means shaped like a cross. And next one is formula. What is that? Formula. Formula means mathematical shape. Actually, formula means already you know about that formula in 10th class, in 9th class, already up to 10th class also we have to listen this word. Mathematical shape. That is called the formula. And malformed. Malformed means badly shaped. What is that? Badly create the shape means we call the malformed. Okay. Now next one, non-conformist. Non-conformist means not thoroughly shaped to others. Not thoroughly shaped to others means others like not have this shape. That is a different. That's why we call the non-conformist like that. That is called the non-thoroughly shaped to others. Now next one, uniform. What is that? Uniform. Uniform means already we wear in school and colleges. You also wearing that uniform. So how like to have having same shape. Having same shape. That is called the uniform. And next, conform. What is that? Conform. Thoroughly shaped to others. I means thoroughly shaped to others means equal. Means conform means thoroughly shaped to others. And next, deformed. Deformed means out of shape. Deformed means out of shape. Deformed means out of shape. And Queoform. Queoform means shaped like a wedge. Shaped like a wedge. Queoform means shaped like a wedge. And information. What is that? Next one is information. Information means descriptive shape. What is that? Descriptive shape. That is called the information. Okay. Are you understand? These are also information and deformed and conform, uniform and malform, formula and non-conformist and cruciform, transform and queoform. These are also we have to call the form. This form means shape. These are also root word of the form. These are also related vocabulary of the form. Are you understand? Okay. Comes to the next one. Anime. Next one. What is that? Next one. Anime. What is the root word? Anime. Okay. Anime. Next root word is anime. So anime means here life. Anime means of life. Okay. Life means anime. Anime means life of life. Okay. Now look at this. So magnanimity. Magnanimity means generous. Magnanimity means generous. And equanimity. Equanimity means keeping emotions calm. Keeping emotions calm. Okay. Equanimity. Equanimity means keeping emotions calm. Means emotions, feelings also we have to showing is that is called equanimity. And inanimate. Inanimate means not living. Inanimate means not living. Means not have a life there. That is called the inanimate. And reanimate. Reanimate means to bring back to life. To bring back to life we call the reanimate. Reanimate. Next one. Animato. Animato means one that is with animation. Means like animation, like the part of the animation we have to call the animato. Animato means one that is with animation. One that is animation. And now next one, equanimity. Equanimity means evenness mind. Evenness mind means same, one mind. Same thing, same mind of persons we have to call the equanimity. Evenness mind. Evenness mind. Equal minds we have to call that. Okay. Next one. Animated. What is that? Animated. Animated means full of life and energy. Full of life and energy. We have to call the animated. Animated pictures means we have to call like that means. Okay, we have to listen already animated pictures. Like that this is also animated means what is that? Full of life and energy. And anime. Anime means here a style of animation in Japan. A style of animation in Japan. Anime means here Japan animation style. This is okay. Now our Indian style now is here style of animation in Japan. Okay. Now next one, animosity. Animosity means ill-spirited. What is that? Ill-spirited means is animosity. Is a bad situation. We have to call that animosity. Okay. Animus. What is that? Animus. Animus means next a strong feeling of dislike. A strong feeling of dislike. We have to call the animus. Okay, these are also we call that. What is that? Telling to the life. About telling to the life. Anim means we have to call the life. Life is anim. Anim means life. This is the related vocabulary to the anim. Are you understand? Animal. Once again, look at this. Animal. What is this? Animal. A creature that has spirit. A creature that has spirit. Means have a life. Animal. Animal means already you know. Creature. Creature that has spirit. Who has the spirit in the body, or we have to call the animals. We have to call the animal. A creature that has spirit. Okay. Are you understand this? Okay, anim means is a life. Okay, root word of the anim. The meaning of the root word life. Comes next one. Ego. Actually, this is not another more another one is out of. I will just explain about this. Okay, now another just actually have not have textbook this ego. But this word, another word I will given to out of textbook. Look at this once, ego. So ego. Ego means actually this root word is ego. Actually, what is that? What is the means of ego? Look at this. Okay. So ego. Ego, this related vocabulary is there. What is that ego? Ego is the root word. This root word means preoccupation, occupation for oneself. Preoccupation for oneself. Means who are thinking about themselves. Means those are also we have to call the selfish. That is called the ego. That is called the persons we have to call the ego people. Okay. That is the root word is ego. That means of the root word preoccupation for oneself. That is the selfish. Okay. Now look at this here. Egotist. Egotist means one who excessively thinks about I. About I. Means one who excessively means thinks about I. Those who are thinking about themselves, we have to call the egotist. What is the egotism? Egotism means thinking excessively about I. Means here already I. We have to listen here I. Means those selfish. Means we have to already we can observe these words. Meanings I. Means selfish. Okay, egotism. Next look at this. Egoist. Egoist means another word for egotist. Another word of the egotist. Okay, this is called egotism, egotist and egoist. These three also explain about the one meaning. Explain about the one meaning. And next one, egomaniac. Maniac. Egomaniac means thinking about I way too much. Thinking about I way too much. That is called the egomaniac. Egomaniac. And next, alter ego. What is that? Alter ego. Another side of oneself. Another side of oneself. Alter ego. Here egotist means selfish and alter ego means another side of also oneself. That is called the alter ego. And super ego. Who is the super ego? That part of the ego or I that watches over what it does. What it does means the part of the ego or I that watches over what it does. That is the superego. These are also observing to others. What are those are done. That is also observing to others. That is called the superego. And egocentrism. What is that? Egocentrism. This is the regarding to oneself and one's own options or interest as most important. Most important means regarding oneself and one's own options for interest as most important. That is called the egocentrism. Egocentrism. And egomaniacal. Egomaniacal. What is the meaning of the egomaniacal? Of thinking about I way too much. Of thinking about I way too much. These are also means these words also explain about the selfish and those one's person side also thinking. That is called the ego. This ego means, what is the root word of the ego? That means of preoccupation for oneself. Preoccupation of oneself. Are you understand? This is the extra word to the out of word this is. Okay, are you understand? Ego. Okay, comes next one. Now look at this. Exercises on vocabulary. Exercises of vocabulary. Already in textbook, backside, what is the vocabulary topic down, so many exercises are given. I think 15 exercises given. In syllabus, 15 exercises only have. First, now we have to learn the 15 exercises only. Okay, now 16 to and 30 exercises also reduce. Okay, reduce our syllabus. That's why we don't learn those. And now first 15 also we have to take the in syllabus. Okay, first one once I will explain about this. Already you know what is that. Already I am discuss in before root words. Then you can understand what is the word meaning, what is this word meaning. Already you can understand. Once look at that matching. Temporal. Temporal means temporal and collaborate, interrupt and monarch and prejudice. Okay? Temporal, collaborate, interrupt and monarch and prejudice. These are also, yes, I have given five meanings. Okay. Now B also given the same, what is those? A to Z. Options also given. So which is the correct meaning of these words we have to understand and write. Okay. First one, work together and be one ruler, and C, to judge before, D, of time, E, burst between or among, which results in disturbing or stopping the work, and F, talk by a single person, usually to oneself, and G, beautifully expressive talking. Okay, now look at this. Temporal. Temporal means, what is the meaning of temporal? Are you understand? Are you know about that? Temporal. Temporal means here off time. What is this? Off time. Temporal means here given to the off time. Okay. And now next, collaborate. Collaborate means what? Anybody? Tell me. Collaborate. Collaborate means work together. Collaborate means work together. And third one, interrupt. What is the interrupt? Interrupt What is the answer? What is the meaning of the interrupt? Burst between or among. Burst between or among means which results in disturbing or stopping the work. This is the match to third one. Okay. And fourth one, monarch. What is the fourth one is monarch. Monarch means one ruler. Means okay, monarch means already you know. This word already you listen in some movies or any place. We have to listen. Monarch means one ruler. Okay, one ruler. And fifth one, prejudice. What is the prejudice? Do you know prejudice? Okay, prejudice means to judge before. To judge before. Okay. Temporal means what is that? Of time. Temporal means of time. And collaborate means work together. Collaborate means work together. Interrupt. What is that? Interrupt means burst between or among. Burst between or among. Monarch. Monarch means one ruler. Monarch means one ruler. And fifth one. And fifth one, prejudice. Prejudice means to judge before. To judge before. Okay? Already one time we have to read. You have to easily you have to gain this matching. Okay? Now comes next one. Next, second one matching. Look at that. Second matching. Monorail. Monorail. And spectacular. Okay, second one is spectacular. And third one, conjecture. What is that? Conjecture. And fourth one, amorphous. What is the amorphous? And fifth one, egoist. And fifth one is egoist. Already now in the last root word is egoist. Ego. Ego already I am explained. No. What is the egoist? Already here you have answers. You have to just read and match these words. Okay. Monorail. What is the monorail? Spectacular, conjecture, amorphous, egoist. These here also have the answers. What is that? Once look at this. To throw an unproven idea a guess. Okay, now B. Having no fixed shape. Okay, C. Who always thinks about selfish person. Okay, and for D. Impressive enough to be worthy of seeing. Okay, and E. A train which uses one rail instead of two tracks. And F. Events of time, record of events ordered by time. And G. Time sequence. These are also have the answers of these questions. Okay, these meanings. First one, look at this. Monorail. Monorail means rail. Rail means already in the question also have the answer. What is that? A train which uses one rail instead of two tracks. Instead of two tracks. Are you understand? Rail. Rail means here easily we have to write a train which uses one rail instead of two tracks. Okay? And next one. Spectacular. What is the spectacular? And spectacles. Already we have to say the C. Spect means what is that? C. Okay, what is the matching here? Look at this. Seeing. Seeing means where the have. Answer. Yes, very good. D. Impressive enough to be worthy of seeing. Impressive enough to be worthy of seeing. That is a spectacular. Okay, conjecture. Conjecture means what is that? Are you on? Read. Conjecture. Conjecture means to throw an unproven idea a guess. To throw an unproven idea a guess. amorphous. That is a conjecture. Amorphous. Morph means what is the shape. But here where is that shape? Having no fixed shape. Yes, good. And fourth one, amorphous means having no fixed shape. That is the answer of the fourth one. And fifth one, egoist. Fifth one is egoist. Where is the egoist? Egoist means selfish. Where is the selfish? Here. Who always thinks about self or selfish person? We call that egoist. Okay? Are you understand? Like this. Once we have to read the all root words, we have to gain the answers. How do you write the matching? Okay? That is. And remaining matchings also, you have to read the vocabulary, and after you have to write the matchings. Already down I will given to the answers. You have to write first, don't say and write, and after you have to check what is the, whether it is right or wrong. Once you have to check and you have to learn these matching 15s also. Okay, that is the examples of given in down. These are also matchings. Overall 15 matchings also have given here. And down I will give the answers also. You have to read. First you have to read and understand, and after you have to make them to correct. Make them to correct answers, and after you have to check whether it is right or wrong. Okay, these are also matchings. Okay, once you have to read the vocabulary, root words. First you have to read the root words, and after you have to match these words. These matchings also you have to do. Okay. Okay, thank you. Okay, 13 and 14 matching, and okay, ma, these are also you have to complete. Okay, are you understand? I think you have to understand my lesson. Okay, thank you.